Hello everyone, today we are going to look at complex analysis, and under complex analysis we are going to be dealing with multiplication and division of complex numbers, since in our previous video we had looked at addition and subtraction of complex numbers. Now let's start with multiplication of complex numbers. Now we are going to use the same variables like in addition and subtraction, which was z1 is equals to a plus bi and z2 is equals to c plus di. And you realize that in these two complex numbers, it consists of both real part and imaginary part. Now let's look at multiplication. Z1 multiplied by z2 is equals to a plus bi times c plus di. Now we multiply each variable with the other. For instance, in this z1 it is a plus bi. Now when we open the bracket, it will be a into c plus di plus bi into c plus di, and we get ac plus adi plus bic plus bdi square. And remember, I square is equivalent to -1. So where there is I square, you put -1. Now in this case, we'll get AC plus ADI plus CBI minus BD. So you realize that where there is I square, we have replaced with -1. Now we categorize this answer into real part and imaginary part, and in our real part is AC and BD. So we put them together, AC minus BD, while the imaginary part is AD plus BC in bracket, and then you put the known number, which is I. And that's all about multiplication of complex numbers. Let's look at division of complex numbers. We are going to use the similar procedure like multiplication of numbers. Now z1 over z2 is equals to a plus bi over c plus di. Now the first step, we are going to rationalize this equation with the conjugate of the denominator. In this case, the conjugate of the denominator is c minus di, since our z2 is c plus di. Now let's look at it. So you can see that a plus bi into bracket, the conjugate of the denominator, which is c minus di, over c plus di into brackets, c minus di. Now let's open the bracket. When we open the bracket, we get AC minus ADI plus BCI minus BDI square over C square minus CDI plus DCI minus D square I square. Remember, where there is I square, we place -1. Now when we replace it, it becomes AC minus ADI plus BCI plus BD over C square plus D square. Now after that, we now categorize them, the real part and imaginary part. In this case, the real part consists of AC plus BD on the numerator, AC plus BD. Then the imaginary part is BC minus AD in brackets I over C square plus D square. And that's our answer. Now let's look at an example. Our example, if Z1 is equals to 3 plus I and Z2 is equals to 5 minus I, find A. The first A, Z1 multiplied by Z2, then B, Z1 over Z2. Now Z1 multiplied by Z2. Now the first thing is putting them in brackets, which is 3 plus I in brackets multiply by 5 minus I. Now we open the brackets, and opening the brackets we multiply 3 into 5 minus I plus I into 5 minus I. Now when you multiply 3 plus 5, it gives you 15, while when you open the brackets now, it will give you 15 minus 3I plus 5I minus I square. And remember, where there is I square, you put it negative 1. So that gives us 15 plus 2I plus 1. And I will find our final answer as 16 plus 2I. Let's look at Z1 over Z2. Now, Z1 over Z2 is equals to 3 plus I over 5 minus I. And remember, the first step we rationalize the question with the conjugate of the denominator. And in this case, our denominator is 5 minus I. So that means the conjugate will be 5 plus I. Now we multiply both sides with 5 plus I. It gives us 3 plus I in brackets 5 plus I over 5 minus I into bracket 5 plus I. Now let's open the bracket, and we get 15 plus 3I plus 5I plus I square over 5 square plus I square. And remember, where there is I square, you put negative 1. And now we'll find 15 plus 8I minus 1 over 26. Now 15 minus 1 becomes 14. So it will be 14 plus 8I over 26. Now, since they are all even numbers, we divide them by 2. So 14 divided by 2, 8 divided by 2, and 26 divided by 2. In this case, we are simplifying. Actually, we are simplifying. So it will be 7 plus 4I over 13. And that is our answer. As simple as that. So whenever you want to deal with complex numbers, first you should identify the real part and imaginary part, and that marks the end of multiplication and division of complex numbers.